What's up guys, Onmaths here, and today we're looking at algebraic indices. Now we've done number indices before, but algebraic indices basically is when the base, the big number, is a letter rather than a number. Simple as that. The same rules apply. So let's look at this first question, which is from AQA, and it's asking us which one of these does not simplify to y cubed. So the easiest way of doing this is just simplifying each of them. So when you times anything by itself 3 times, you get that thing, which in this case is y, to the power of 3, because it's times by itself 3 times. So that, in fact, is simplified to y cubed. So that's not the one we're looking for. We've got y to the power of 4 divided by y. Now the first thing to realise is when you've got a y on its own, it's actually to the power of 1. Second thing to remember is that when you divide powers, what you do, or divide indices or powers, whatever you want to call them, you take away the indices. So this becomes y to the power of 4 take away 1, which 4 take away 1 is 3. So that actually does simplify to y cubed. The next one is y squared minus y. Now again, remember y on its own is y to the power of 1. This one's, the rule here is that when you times powers together, you add the indices. So it's going to be 2 plus 1, which is y to the power of 3. Process of elimination, we probably think this last one is not going to, hopefully, otherwise we've made a mistake somewhere. So the rule again is you take away the indices when you divide. So it's 6 take away 2, and that is y to the power of 4. And that does not simplify to y to the power of 3. So it's this one here that we circle. Next up is our OCR question, and we've got a collecting like terms question first, but I left it in because, well, why not? So we've got a 5x here and a takeaway x here. So 5x takeaway x is 4x. And we've got a minus 6y plus 3y, so that's going to be minus 3y. We've got a whole video on basic algebra, so check that out if you're not quite sure how to do that one. We're more interested in part 2 and part 3. So we've got a divide here. So when we have a divide, what we do is we take away the indices. So it's going to be 8 take away 2. 8 take away 2 is 6, so it's going to be w to the power of 6. Now this last question's really complicated, but what we can do is we can break this up and make it a bit easier for ourselves. So when we have a number next to a letter or a letter next to a letter, there's actually a time sign there. So what we're going to do is we're just going to put those time signs back in. Next, what we're going to do is we're going to pair up things that can be multiplied together. So we're going to put the numbers first. Remember, when you're multiplying, it doesn't matter which order we do it. And then we're going to put the C's. And then we have that D at the end. So we're going to do 5 times 3. Well, that's 15. We're going to do C to the power of 2 times C to the power of 1. Remember, when you multiply them, you add the indices. So that's going to be C to the power of 3. And then we've just got that D at the end there. So the answer is 15 C to the power of 3 D. Finally, we've got our Edexcel question, and you can see here that we've got the same sort of question first of all. M to the power of 3 times M to the power of 4. When you times ones with the same base, so it has to have the same letter here and here, you add them, so it's going to be 3 plus 4, which is going to be M to the power of 7. So that's going to be M to the power of 7. Now, this next one, there is a rule that says if a power's on the outside and a power's on the inside, you add them. But what we've got here is you times them, you don't add them, you times them. So if we've got just p to the power of 3 and then with a cube on the outside, what that would be is p to the power of 9. Okay, you times them together. But the problem with this question is there's more than one thing inside the brackets. Now there is an easier way of doing this. What you do is you write down the thing inside the brackets, the amount of times that it tells you to on the outside. When you cube something, you're timesing it by itself 3 times. So we're going to have 5np cubed times 5np cubed times 5np cubed. Now we do the same thing as we did on the previous question. What we're going to do is we're going to put the time signs in, okay? And this does take a bit of time, but the amount of students who get the wrong answer on this question, it's definitely worth doing for the 3 marks. So we're going to put the numbers together. So it's going to be 5 times 5 times 5. We're going to put the n's together. So it's going to be n times n times n. And we're going to put the p's together. So p cubed times p cubed times p cubed. So 5 times 5 times 5, and this is a calculator paper, so you could just quickly do it on a calculator, but you should know it's 125. N times n times n is n to the power of 3, and then p cubed times p cubed times p cubed. Remember, when you times them, you add the powers together, so 3 plus 3 plus 3 is p to the power of 9. And that's our answer, 125, n cubed, p to the power of 9. So what you could have done, and I find that students don't often have much success with this, but if I write it a bit bigger, you can times the 3 and the 3 there to make the p to the power of 9, which we talked about before, times that 3 by the 1 there. Remember, if there's nothing there, it's to the power of 1, and 1 times 3 is 3, so it's n to the power of 3. And then what last thing we do is we put that cubed with the 3 there, with the 5 there, so it's 5 cubed, which is 125. I don't find students do that very well, and everyone I've taught this method to, where you just times it by itself 3 times, gets the right answer. So it's up to you, whatever you have success with. Okay, this last question is quite a tricky one as well. The first and most important thing you realise is that over and divide are the same thing. So this is exactly the same as saying 32 q to the power of 9 r to the power of 4 divided by 4 q to the power of 3 r to the power of 1. And you've got to remember that that's the power of 1 there. Okay, what we're going to do is I'm just going to write it out again but bigger, so we've got a bit more kind of space to play with here, and I can kind of show you it, what we're doing a little bit easier. So 4q to the power of 3 r to the power of 1. So what we're going to do is we're going to do each of these individually. So I'm going to do the 32 divided by the 4. That's all I'm going to do. So 32 divided by 4 is 8. Then I'm going to do the q to the power of 9 divided by the q to the power of 3. So remember, when you divide them, you take away the powers. So it's going to be 9 take away 3, which is q to the power of 6. And finally, we're going to do that r to the power of 4 divided by the r to the power of 1. Again, when you divide, you take them away, so it's going to be r to the power of 3. And that's our answer. So quite a tricky one there, especially, well, mainly B and C for today's video. I think question B and C are probably among the hardest algebraic indices questions you might face on the foundation paper. But you can see that actually it's just those basic rules just applied again. We didn't do anything that we didn't know or had to sit down and work and learn stuff for. Question B was just understanding that cube means times itself 3 times, and then we've just used the basic rules to work it out. Question C, again, just understanding that over means divide, and just doing the numbers first, then the q's, then the r's. And that's quite a nice 5-mark question there, just from understanding the basics of algebraic indices. But I hope you found that video useful. If you did, please click like, and please keep your comments coming in. If you've got suggestions of stuff for us to do after the summer school finishes, please keep those suggestions coming in. If you want to see more from us, release videos every single weekday at 9 o'clock in the morning. Just click subscribe and the bell icon to make sure you're up to date with all the videos we release. If you haven't already, which I'm sure you have, you can click the link that magically appears above this video now to take you straight through to the onmaths.com website, where there's loads and loads of free resources to help you with your maths going forward. Otherwise, thank you very much, and I'll see you tomorrow.